So yeah, welcome in another video about Proxmox. This is a series about Proxmox backups, but that video is going to be like general video. I'll show you how to create a virtual machine in Proxmox. In this video, we're going to install Ubuntu server. So yeah, let's start. To create VM, first we have to get the ISO image of a system. Maybe you have the ISO image of that system on your disk, or you can go and download. I'm going to go to Ubuntu web page and I'll download the Ubuntu server, the latest one for today. Today is January 2026, so we're going to get the latest one. So that's the Ubuntu page to download the latest version of a server. You can download desktop, it doesn't have to be server, of course. But somehow I'm always grabbing the server version. So yeah, click that link, get the version. It's going to be around 3 gigabytes. Download it. Yes, I click the button. I'm just waiting to download to start. Yes, downloading. Let's wait when it's done. So it's ready. Download is ready. Let's go to Proxmox. And now, yes, so I want to install that Ubuntu VM. I have one running here. Sorry, on this one, Ubuntu test. Here I have Ubuntu container. It's not VM, it's a container. Lexi container, LXC, but we're going to create VM. So yeah, we need to download that ISO to Proxmox. So click on that local disk. Only that one probably will allow you to upload the ISO images. If you click different disks, that option is not available. I don't know what kind of idea they had in head to create that. For me, I should be able to download it wherever I want, but that's the way it is. So click on that local on your node. Have local on each node, local disk, ISO, upload. Here, select the file. I'm going to select that Ubuntu ISO. I just download it. Open and click upload. Just wait when it's ready. All right, download is done. It's okay, status is okay. Let's go here. Ubuntu is there. So now we can create the VM. So let's click create VM. Let's pick the node where we want to create it. I want to create on that node 3 lab because that's my lab number 2 node with quite big disk, 5 terabytes. You can see here the tank is 5 terabytes. VM ID is the ID of virtual machine, usually is assigned automatically, incrementally by Proxmox. Just pay attention because you can't have VMs with the same number. That's going to be a little bit naughty to have something like that. Don't do that. But you can change the number to 107, doesn't matter. But I have VMs 100. I don't want to set it to 100. That's going to be fail. I don't want to set it to 102 as well because I have 102 running as well. So 103 is good for me. Name, let's name it Ubuntu server test. Start at boot. Yes, we want to start it at boot. Why not? That should be everything on that page. Let's click next. OS. Let's pick the storage. So it's on that storage, and let's pick the ISO that we downloaded. That's the Ubuntu server ISO we downloaded before. Type will be Linux, of course. Kernel version is this one, latest one. Let's click next. In machine, we select Q35. Why to select Q35? Because Q35 is a modern virtual chipset and is usually the right choice for Ubuntu Server VM. It emulates a new Intel platform with PCI instead of legacy PCIe instead of legacy PCI, which kind of matters for performance and compatibility. You get cleaner device layout, better support for modern hardware features, and all those new quirks with the virtual I/O devices, GPU pass-through, NVMe's, and all those sorts of stuff. So basically, that is at this moment like a much more modern one. When we selected that Q35 in BIOS, we should select that OVMF UEFI BIOS. When we selected OVMF UEFI, we have now options to select in EFI storage. So let's select, we're going to select that 5 terabyte disk. What is it? That's small storage, but very, very small one, tiny one. It's managed by that VM because that UEFI needs to store a config somewhere, right? So it stores things like boot entries, boot order, secure boot states, like firmware variables and stuff like that. So it needs to hold somewhere data for that BIOS, and it will store it here. Don't worry, we don't need to manage that one. The next one here is SCI SCSI controller. Let's leave it like it is. We're not going to play with that. And QEMU agent. Let's enable it. And what is QEMU agent? QEMU agent is like a service. It's a small service inside the VM and allows Proxmox to communicate directly with the guest OS. When it's enabled, Proxmox can do things like clean shutdowns, reboots, uh, report the VM IP addresses, freeze file systems during backups, which is quite important, and basically manage VM more safely. More safely. Without it, the Proxmox will have to like force some actions on it through hypervisor level, which is like less clean. So we need to have this enabled, but that's not enough. In Ubuntu, we need to enable that. Just check if it's enabled. Install that QEMU system agent and enable it. We're gonna do that later on. So yeah, let's click next. Yeah, so let's pick this device SCC is alright. Storage, let's store that on that 5 terabyte. Disk size for that Ubuntu shouldn't be like big, but like let's make it like 40 terabyte, sorry, 40 gigabytes. Cache, no cache. We don't want to play with caching here unless there's a very sensitive data and we don't want to lose it when there's like a power off for our VM. Discard, yeah, let's select discard. Discard is quite nice option, nice to have because the discard, it's looking after the hygiene of the VM. When something is deleted on VM, the host system still thinks that those blocks are in use because they're not reported like those blocks are free anymore because something was written there, and it still sees like that space is taken, those blocks are taken. And this, what discard does, the trim, basically it makes those blocks report those blocks as free when something is deleted. So the host doesn't see the VM size when it's full or something like that, right? So that's kind of mental modem. So it's always nice to have. IO threads is nice to have as well. In that case, what it does is each disk uh, gets its own thread when doing like input output works with the disk, and it's like it doesn't block the thread that emulates CPU within the virtual machine. So basically, it separates the CPU emulation from input output works, which is good to have. SSD emulation, this one I leave disabled because I don't have SSD disks. I have HDD disks. This one will be better if you have SSD disk in your system. Reads only. Now we're gonna leave it disabled. We don't want to leave that VM as just read only. Backup, yeah, this one is enabled because we usually want to back up our virtual machines in Proxmox backup server. That's what we actually going to do. Skip replication. This one is just relevant if we want to use Proxmox cluster replication, but we don't want to do that. And async IO. This one default is cool, is quite modern. So we're going to stick with that one. Next, the CPU, the processor. This page allows us to set up the CPU. We're going to play mostly with sockets and cores. Socket is like how many CPU sockets you have on the main board. Usually it's like one, right? So, and how many cores the CPU have. If you see like we have two sockets and two cores, so total cores will be four for the system because there's two CPUs, virtual CPUs, and two cores per CPU, so it's four. But sticking with one is like good for us because adding more, it changes the topology of the CPUs and everything on the main board. So the virtual machine is going to see like two CPUs. With two CPUs, there's like different kind of logic to operate those two CPUs. There's like will increase the Linux will increase the scheduling complexity and slightly reduce the performance. Actually, we're not gonna get more gains here because if you know something about multitasking, multi-threading, to create thread, it takes time, and especially we have like more CPUs, the communication between them, synchronization, and then joining all those operations together takes time. So we're not going to have any benefits of that. So it is better to increase the number of cores, but that is small VM, so we're going to use just two cores. The type, we're going to stick with that in x86 because that's very kind of default, very good one. We don't need to play with that one here. So yeah, we're not gonna add any of those. So let's click next. The memory page. Let's set some memory now. So let's think about minimum memory. Minimum memory, let's keep it like 2 gigabytes, but we can increase maximum memory. And my host has 32 gigs of memory, so I can use like maybe 8 gigs. Sorry, 2048. Let's set it like that. So maximum will be 8 gigabytes, minimum is 2 gigabytes, and with this ballooning device enabled, what we can do with that, not what we can do with that, but what the Proxmox will do that when the host machine for that VM really needs memory, and that VM has available memory, the host machine will actually use that memory, right? So it will keep it like minimum 2 gigabytes, but if there's like more free memory on that VM, the Proxmox will grab that memory and use it if it's not needed for VM. If we keep those two values, 2 gigabytes for both, the valuing device is like pointless to have here because the maximum and minimum is 2, so there's no room actually to use the memory. And allow KSM, is also quite cool feature. We can enable that. So this one is quite good, because when there's like pages in the memory that are identical between VMs, Linux actually can reuse those pages. So this is quite nice. Is useful when there's few similar Linux VMs running. That feature can be very useful. So let's click next. Network. We're going to stick with the defaults. Uh, yeah, nothing to change here. Next, we should review it and maybe start the VM when it's created, so we can start the Ubuntu installation. We can see like this one has been created. Let's go to console, and yeah, we can start installing the Ubuntu. Let's pick the English UK. I want to have Ubuntu server minimized. That's going to be the IP assigned to that machine by my DHCP and my local network. That's the IP. Below is the MAC address of that card. Let's select done. Reading some packages lists. Done. Asking us if it should use the entire space of the disk. Yes. Let's confirm everything is fine. Yes. Done. Yes, we want to continue. Your name. So my name. Server names is going to be Ubuntu test VM. Done. Skip for now. Install OpenSSH. Yes, we want that. SSH key we don't want to import. Done. We don't want anything from here. Done. Yep. And installing the system. Installation is completed now. So we can reboot. So yeah, we are here. So let's log in. I'm using the same username and password that I typed during the installation. Yeah, we are inside the Ubuntu server. So always good to run update. So sudo app update. Updated now. Maybe upgrade. Yep, great. Now let's check if QEMU actually is enabled by default. Systemctl status QEMU. Sorry, QEMU guest agent. No. Let's install it then. Sudo apt install QEMU guest agent. Yep. So let's check if it's enabled by default again. Ooh, dead. Let's enable it. Enable. Now, QEMU guest agent. Now QEMU is running, so we're happy. So yeah, that's about it. This is how to install Ubuntu server as VM on the Proxmox.